So today we're going to start section 9.1, and this section is about sequences. Sequences, sorry, just a sec. Are something that we encounter all over the place. We're going to specifically talk, of course, about mathematical sequences, and we'll start with our definition for that. A sequence is a function whose domain is the natural numbers. I'm going to pause there for a moment and ask if you remember what I mean when I say natural numbers. What are natural numbers? The counting numbers. Okay, they're the ones that you naturally count with as a young child. So we're talking about 1, 2, 3, 4, and so on. So it is a function. However, so we'll say though, subscript notation sorry, just a sec. So though subscript notation is commonly used. So if you think about it, sometimes we write function notation in a way that shows where it's mapping to. So like the number 1 corresponds to subscript 1 for a function A. So if we have the second element in the sequence or the number in the sequence, that one is A2, and so on. The values A1, A2, A3, ... are the terms of the sequence. We would call A sub n the nth term. Of the sequence. All right, so what we're doing in chapter 9, as we start this, I just want to let you know, this is my favorite chapter in the whole course that we're going to do together. It's often people's least favorite chapter. I really feel like it's very much like a puzzle. So do you guys remember doing different, I can't remember what they call it, but it's the integration section inside of Calc 2 where you have to figure which integration method to use, and it's like, is it trig substitution, or is it this like special thing where I complete the square and do something else like that, kind of puzzle-like? I feel like this section is much, not this section, but this chapter is much like this, okay? So we're starting with something pretty basic, and this is sequences. Whoops. So let me show you what specifically we're meaning by a sequence. So we're going to give you the first, we're going to find the first 5 terms of the sequence. And in order to do that, I have to give you the nth term. So A sub n is equal to 4 over n factorial. Okay, so I chose this example on purpose because I wanted to remind you, in case it's been a while since you've seen it, what a factorial is. So does anybody remember what it means when we talk about, I'll give an example specifically. Let's just say 5 factorial. What does that mean? Yeah, and I'm going to write it backwards of what you just said. I'm going to start with a 5. but it's the same thing, right? So you start with whatever that value is, and you multiply it by every whole number value below it until you get to 1, and you stop at 1. So counting numbers, actually. So all the counting numbers down, and then you'd multiply it out. Okay, so that's factorials. So as we're taking a look at this, what we're asked to find here is what a sub 1 is, and a sub 2, and a sub 3 all the way up to a sub 5. And as we do that, what we're being asked to do is evaluation. And you guys have been doing this since middle school, all right? So you're just substituting the value in, simplifying what you get. And when we're done doing this 5 times, we're going to write them in a list in order from the first one we've gotten until the last one we've gotten. So on this one in particular, it would be 4 over 1 factorial. And what is that? It's just 4. A sub 2. Well, it'd be 4 over 2 factorial. But what is 2 factorial? It's just 2. So 4 over 2 would be 2. How about a sub 3? What would it look like when I write it sort of in this first form?
4 over 3 factorial.
Right, 4 over 3 factorial. What is 3 factorial?
2/3.
Yeah, it's 6, and then I would have 4 over 6 that would reduce to 2/3. Yeah, exactly. How about a sub 4? Okay, so let me pause and offer a suggestion at this point that might be helpful. The bigger factorials get, sometimes it's not super nice to actually multiply them all the way out. Not that 4 factorial is particularly huge, but it's kind of nice that there's a 4 on top and a 4 factorial specifically in the bottom. So if I think about writing a factorial out, a lot of times it will actually simplify and I don't actually end up having to multiply all of it together to begin with. So you do need to remember, of course, that the denominator still has the 3, 2, 1 in it, and it doesn't just become 3 times 2 times 1. But this would end up giving you 1 out of 6. So far, so good? Okay. Our last one that it's asking us for anyway, of course, this process goes on forever, but we're only asked to find the first 5. A sub 5 would be 4 over 5 factorial. And again, I would still suggest doing what I did on the last problem. It's not so nice in the fact that you look at it and you say, oh, look, there's a 4 on top and a 4 on bottom, but there actually is a 4 on top still and a 4 on bottom, right? So I can still,
1 over 3.
yeah, that's right. I can still reduce the 4s, and then I have 1 over, what'd you say, 30?
30.
It is, good. So these are my 5 terms. Do you have to show all the super detailed stuff I had written there? Not all of it. You guys are math majors, I get that. But you should show me something along the way. If all you do is give me the answer to this question, that's not what we're looking for, okay? The reality is that your calculator can do that for you. I'm not teaching you how to do that because I don't find that to be a very good use of our time. But it will. It'll just give you a series of numbers, a sequence of numbers if you ask for it to do something like that. So we're actually looking at this being 4, 2, 2/3, 1/6, and then 1/30 as our answer to our question. Make sense? All right. We will stop there today.